Hi. So the goal of this lecture was to show you a little bit of the history of software development processes and how we started with some sort of a rigid process like the waterfall, and then we noticed that iterative development was fundamental, and then we got to the agile methodologies where it is the state of the practice today. So the waterfall method, as we call, it looked like this picture. We had different phases, for example, requirements, design, implementation, testing, and deployment. And as soon as you're done with the requirements, then you can start the design phase using the requirements as an input. As soon as you have the design done, you can then start the implementation using the design phase as an input. And the design phase was about designing and thinking about architecture, right? And then so on and so forth. So this was the waterfall method, and definitely it had some nice ideas, right? So all the phases that you're seeing there, they are quite compulsory when you want to do software. You cannot do software without doing some proper requirements phase, without thinking about architecture, without implementing software, without testing it, and without deploying it. And if you do this in the order that you can see in the picture, you minimize the risks because you can only do design if you know the requirements. You can only do implementation if you're sure about your architecture. You can only do testing if you have everything implemented. So in a way, the goal of the waterfall was to minimize risks, and that was what they tried to do. And you can actually read the original paper where the waterfall is described. It is from the 70s. And funny thing, the word waterfall doesn't appear in the text. But then we started to see some problems in practice when trying to implement the waterfall. And the exercising lecture was for you to think about them. You thought a lot about of these problems. Let's just go through a few of them. So the requirements phase at the very beginning, and only at the very beginning, we noticed that it is just too hard to elicit all the requirements. Because maybe your user doesn't really know what he or she wants, and requirements, they change quite often, right? The real world changes fast and your software needs to adapt. So it was just very hard to do requirements at the beginning. And because of this, well, mistakes, they kind of start to propagate throughout this chain, right? So you go to the architecture phase, and then it was just very hard to decide which architecture to implement. And in practice, we saw lots of under-engineering, meaning doing architectures that were not enough for the problem, or over-engineering, doing something way more complex than what you really needed. Then the implementation phase, and in practice we noticed that when this phase started, everyone had the feeling that the project was already late because we worked a lot, but there was no software for the final user to see. There was no return of investment. So in practice we saw lots of pressure into the development team in day one. Testing was just too hard to do at the very end. A huge software to be tested is not easy, as we discussed in this testing lecture. So then what we notice is this huge loop between testing and implementation. So the testing team, they find lots of mistakes. It comes back to the implementation team, they fix it. It goes to testing again, and they find more mistakes. So a huge loop between these two phases. And of course, this costs money, right? And deployment, this was the first time that the customer had some real return of investment, but the cost of change is then too high. So we took too long to try to experiment, and well, this is then the waterfall in practice. So we don't like it, and then we started to discuss how to mitigate these problems, and we talked about doing all these phases. But instead of doing this in the waterfall way, so I need to do one and then the other, we thought about doing this in small iterations. So we do a little bit of requirements, we do a little bit of analysis and design, we do a little bit of testing, we learn from everything we did, and then we repeat it. We do a little bit of requirements and planning again, and etc. And when we feel comfortable, we deploy to the final user so that the person can have ROI from the very beginning. And this is what we call iterative and incremental development. And it is iterative because we do many small cycles, and it is incremental because we then deploy it. We deploy small pieces of functionality quite often to our final user. And then I made the joke about how we would do the flower in an incremental way. And this is how it looks like. So if you notice, we have a flower from the very beginning. The flower on the left is quite ugly and very simple, but it is a flower already. And then over time, we just improve our flower until we get to what we want. And this is what we want to do with software. So in the first cycle, in the first increment, we just do some very small piece of software, but hopefully it looks like our end final software from the very beginning. It is a very small thing of the software, but it works and the user can get some feedback. So then we went to this formal definition of what incremental and iterative development process means. And then we started to see some implementations of this. And we saw the RUP, so the unified process. And if you look to this very famous picture that describes the RUP, we can see that we have a little bit of everything. So if you just look vertically, you can see that we have a little bit of business modeling everywhere, a little bit of requirements everywhere, analysis, implementation, testing. They all quite happen at all points, right? Of course, at the beginning, you can see that at the inception, you have lots of business modeling. You need to learn more about the problem, and then this becomes less intense as we go. But we have a little bit of everything. So this is the idea. But actually, one thing that I don't like from this model is that you can see that deployment, it happens very slowly at the beginning and a lot at the end. That is okay. This means we're deploying from the very beginning, but maybe we can do even more, right? We can deploy even more often to the final user. And then we went to the Agile manifesto, and the Agile manifesto was something that came up after a meeting with a bunch of very good developers. So in 2001, they got together and they decided to think about their development processes and what were the good things that they were doing, what were the bad things that they were doing. You can read the entire history at this web link. And while the Agile manifesto got so popular, and as you can see, Agile and Scrum and Kanban, they are all different flavors of Agile methodologies, they got really popular. And Agile has four main values, so individuals and interactions over processes and tools, and this one is about making sure that people can work together and can collaborate together, and making this to happen is maybe more important than choosing a specific tool. So just choosing the tool, for example, I'm going to use Jira to store my issues, this will not solve your problem. Your problem is more about people and make sure that these people can work together. Working software over comprehensive documentation. This value was focused on let's give return of investment to our customers from the very beginning. Working software means more than comprehensive documentation. And in this value, these Agile people were fighting the problem that we had in industry before, which was let's do lots of documentation in many different forms because this will give us some certainty about what to build. And Agile people, they basically prefer to do documentation, so documentation is important for them, but the way for them to measure their progress is by how much software they are delivering. So working software is something more important to them. Customer collaboration over contract negotiation. Having contracts is definitely very important, but what will make the difference when it comes to build the right software is to make sure that your customer is on board and this person collaborates with you all the time and this person is part of your team. And finally, responding to change is more important than following the plan. So Agile methodologies are about embracing changes. So we accept the fact that software will change over time. It will change very fast, maybe, and we need to find a way to respond to these changes instead of just saying, well, we need to follow the plan. How can we adapt? Adaptation is maybe a synonym for Agile. The Agile Manifesto has many principles behind it. I'm not going to go through all of them, but our highest priority is to satisfy the customer through early and continuous delivery of valuable software. So this is about return of investment. We welcome changing requirements. So we want to embrace change. We want to adapt. We want to deliver working software very often, from a couple of weeks to a couple of months, but shorter is better. Business people and developers must work together, so collaboration. Motivation is fundamental, so like agile methodologies, they believe in the fact that motivated people can produce more, so we need to come up with a nice and good environment for developers to work, otherwise we cannot produce anything. The most efficient and effective method of conveying information is face-to-face conversation, so agile methodologies, they do like to meet face-to-face or to have as much communication as possible. You should not hide behind your emails, and this is what they value. Working software is how we measure progress. Sustainable development, it has to be sustainable, right? We cannot just do 20 hours of work a day. This is not sustainable. And the question is, how can we get to this? Continuous attention to technical excellence and good design enhances agility. This is one of my favorite points in there, which means that while we are accepting changes even late in the process, but for us to be able to change our software quite often, we need to have a good source code behind it. So we have to have good design decisions in there, nice architectures, so that we can our software can be flexible. We can implement new things and we can change things without having to re-implement everything. Simplicity is fundamental. The best architectures, requirements, and designs, they emerge from self-organizing teams, and in here they are saying that as soon as you have a team and this team can self-organize, so the team decides how they do the job, the best decisions will naturally emerge because you have a team composed of amazing people, and these people together will come up with the best decisions. And at frequent intervals, the team reflects and they adjust. This means continuous improvement. We're always looking to what we're doing and looking for ways to improve it. So this is a quick overview of an agile methodology. We plan, but we plan for a small cycle. As soon as we plan, we then do a small cycle and we build software. We try to collaborate as much during this process. At the end of the cycle, we either release it to the final user, or maybe it's not possible to release because that won't be useful enough in production, but then we learn from it and we repeat. Then we had at the end some questions. Do you think agile methodologies always fit well? This is for you to think. Then I showed some papers showing that we do have some anecdotal evidences about agile methodologies in practice. Things like it does improve communication with the customer. Customer is more satisfied, but it's not very easy for them to adapt. Adopting agile methods can take time and effort. Developers feel more productive. They feel that they deliver software with better quality. But doing these kind of studies can be quite tricky, and software engineering researchers are still not completely happy with the way they are doing these kind of studies. So there's still lots of room for improvement. Can we be agile without technical practice? We discussed this a bit. Think about it. And in future videos, we're going to see that we do need technical practices like pair programming, test-driven development, refactoring, the ideas of extreme programming in general, but we get there. I pointed you to other things, and this is this lecture. See you next time.